So 76 is the first example. It says f of x is equal to log base 5 of x plus 6. And in this set of directions, they're asking you to find the domain. So there's always a couple ways to do things. So since we just talked about graphing, could y'all tell me what the transformation would be for f of x equals log base 5 of x plus 6? It would be left 6. So one way that you could do this one, okay, some of them are more complicated, but one way that you could do this one is you could just sketch the graph. I mean, just a basic stretch. So we sketch. So we know we'd have to go to the left 6. And there would be a horizontal asymptote there. And it really would not matter what the graph looked like. I mean, you could just kind of put anything here as long as you know that your log graph is going to approach that asymptote. Okay, so I could just kind of just sketch something in. It's not going to touch that asymptote. So if they're asking you to find the domain, remember domain is x's, so from left to right, what would be the domain of this graph? Okay, what do I put on -6, a parentheses or a bracket? I put a parentheses because my graph is never going to have an x value of -6. It's just going to approach that broken or that dotted line called an asymptote. Okay, so that's one way you can find the domain of a log function. You can think about what it looks like graphically. You have a grapher in your launch pad. You could put any of these functions in that grapher. If you have a graphing calculator, you could put them in the graphing calculator. If you have an app on your phone, you could put them in the app on your phone. So anytime you're talking about domain and range, and when you get to calculus, Ms. Clem is going to say make a graph. Okay? Because one of the best ways to find domain and range is to actually look at the graph. Look from the left to the right for the domain. Look from the bottom to the top to the range. Okay? That's one way you could do it. Another way you could do this algebraically without the graph is the definition of a log says this value that I'm highlighting, if we go all the way back to our notes, it says that value must always be greater than 0. That value must always be greater than 0. So you could take what follows your little base, whatever that is, and in this case it's x plus 6, and by definition of any type of log, even a natural log, that value must be greater than 0. And then you would just solve that for x, and that would also tell you your domain. So that says that if we solve it for x, if x plus 6 has got to be greater than 0, then all of your x's must be greater than -6. And then you would say your domain goes from parentheses -6 to infinity. I don't care how you find the domain, okay? If it's a pretty simple graph, you can graph it and think left to right for the domain. If it's not a simple graph, then you'll take what follows the base, set it greater than 0, and solve it. And write the domain in interval notation, okay? So my next example is a little bit more complicated graph, and we'll find the domain with a second method by setting that value greater than 0 and not doing the graph because we don't graph any of these, or you're not going to now. So on number 80, they're still asking you to find the domain. If you wanted to put this equation in a grapher or a graphing calculator, you could. But we can just use algebra to find the domain. And by the way, LN stands for, y'all remember? Natural log, and it's backwards, LN, natural log. Remember when we did the little stations, the first example I gave y'all was something like e to the third. And E is, it's on the LN button on your calculators if you have to hit second LN. LN is natural log. It's one of our common logs. Anybody remember what its understood base is? I've just given you a hint. Its understood base is E. We won't need it to find the domain here. All we need to know is we really don't know what this graph looks like. You could put it in a grapher, but it's not something that we've graphed before. And so you would take what follows your base, which is x minus 7 squared. And by definition of a log, x minus 7 squared has to be greater than 0. Okay? Now, that looks pretty simple to solve, but since it's a quadratic, anybody know why I would say since x minus 7 squared is a quadratic? You may remember what a quadratic equation is, what it has to have in it to be quadratic. Use the quadratic formula. Remember ax squared plus bx plus c. Is that anywhere stored in your memory? Ax squared plus bx plus c is a general quadratic equation. A quadratic equation has a highest exponent of 2. So since this is a quadratic inequality, we have to use a little bit more algebra 2 on it. We can't just add 7 to both sides. We can't just take the square root of both sides. So back in algebra 2, we learned when we had quadratic inequalities, and you won't always have the same two factors. I'm going to write it out in expanded form here. So x minus 7 squared is really x minus 7 times x minus 7. So since this is an inequality, we have to take each one of these factors and we have to set them equal to 0, and we have to put that number on a number line. So those two factors are exactly the same. So when you set them equal to 0, you get x is equal to 7. Okay? If the two factors would be different, then you would get two different numbers, and you would have to put the two different numbers on your number line. Anybody know whether it's an open or a closed circle at 7? It's open. You're right. Why is it open? There's not an equal to. Okay? And this is where the next step is to test. Does anybody know what we have to test? What are some numbers that we might want to test? 6 and 8. All right, we want to test to see where to shade. If we just have one number on a number line, we could shade to the left of that number, or we could shade to the right of the number. Okay, we're not going to go back into our LN. We're just going to go right back into x minus 7 squared must be greater than 0. And we're going to see if 6 will make that true. So 6 minus 7 is negative 1. Negative 1 squared is positive 1. Is positive 1 greater than 0, true or false? True. Okay, so if 6 makes x minus 7 squared greater than 0, then that's enough to prove everything less than 7 makes it a true statement. So you would shade all the numbers to the left of 7. And then let's see if we're going to shade to the right. So to see if we're going to shade to the right, you would pick any number to the right of 7. Sean picked 8, so we're going to try 8. Go back into x minus 7 squared. It's got to be greater than 0. Would 8 make that true? Yes, it would. Okay, if 8 makes it true, then that's enough to prove that every point greater than 7 would also make x minus 7 squared greater than 0. So in this specific graph, which we really don't know what it looks like, but algebraically, we know that our domain goes from negative infinity all the way up to what? To 7 parentheses. Anybody know what symbol I have to use when I have two interval notations? Union, parentheses again, and then our domain goes from 7 to infinity. So if we're stating domain or range and we have more than one interval, we use a union symbol just to say, hey, all the x's go from negative infinity up to 7. Okay, and we have some more domain values, and those go from parentheses 7 to infinity. So if you get a graph that has a squared on it, don't try to do this one by sketching out the graph unless you have some type of grapher, because we've not graphed any ln of x minus 7 squareds. Okay? So apparently that graph would have a piece on the left of 7 and another piece on the right. Maybe you'll graph some of those when you get to calculus. It's nothing that we graph in Algebra 2 or in Precal, the x minus 7 squared part in a log. But we do know how to actually find the domain there. Okay, so let's look at these real quickly. This will probably be the hardest part of your homework. So when they're asking you for domain, you can either graph it if it's something that you know you can graph. If not, you're going to take what follows your base and you're going to always set it greater than 0. 76 was an easier problem because the x plus 6 was not squared. So you just said x plus 6 is greater than 0, solve for x, that gets you your domain. If you have any type of x squared in your problem, then it's a harder problem like number 80, and you'll have to solve it like a quadratic inequality. You'll have to look at the two factors, set them equal to 0, put that number or those numbers on a number line, do open circles. It's never going to be greater than or equal to, because in the definition of a log it says it's got to be greater than 0. Then you're going to test any area that you could possibly shade. You'll test any area that you can possibly shade. You'll decide whether you shade there, and then you say the domain is what you have shaded. Any questions about 76 or 80? All right, next set of directions say evaluate, or actually this is the set of directions all the way to the end. So you just have two set of directions in your homework. Find the domain and evaluate. So last set of directions are going to say evaluate, and these will be fairly easy. Evaluate or simplify without using a calculator. Evaluate or simplify without using a calculator. Alright, so I have picked number 82. 82 says log 1,000. So we've already talked about natural log. Ln has an understood base of e, and what does log have an understood base of? 10. Okay, so you're going to have to think that there's a base 10 there. So this problem says 10 to what power is equal to 1,000? 10 to what power is equal to 1,000? And that would be 3. 10 to the third. 10 to the second is 100, so 10 to the third would be 1,000. So you won't have much work with these. They're asking you to do them without a calculator. 84 is asking you for log. They don't write a base, so that's understood base 10. And then 10 to the 8th. So again, you're thinking about the understood base. You can write it if you want to, but it won't be there. So this one says 10 to what power is 10 to the 8th, and the answer without a calculator would be 8. Next one is 86. 86 has a 10, and in the exponent it has a log. So this is one of those that I said I can explain it to you, but basically both bases in this problem are the same, and it's no different than 84, except it's just swapped around and the log is up in the exponent. But up in the exponent, the base of that log is an understood 10. And so the two bases are the same, and they literally just cancel each other out, and the answer is going to be 53. Same thing's going to happen in number 88. You're going to have ln of e. The base of ln is an understood e. And so the question is e to what exponent is equal to e? E to what exponent is equal to e? 1. E to what exponent is equal to e? 1. Number 90, ln e to the 7th. ln e to the 7th. Again, the understood base is e, so you're saying e to what power is e to the 7th? The bases are the same, they cancel out, and you get 7. When we start to solve, and we will start to solve, if you don't understand this little simplifying process, you'll start to get confused because we'll be solving these big log equations, and some of your logs will simplify out, and you won't know that they do, and all that kind of good stuff. All right, two more. 94. E to the ln of 300. E to the ln of 300. It's so easy you think you're wrong. It's just 300, because the base of the ln is e. The bases are the same, so they just cancel out, and you get 300. Last one, 98. E to the ln 7x squared. E to the ln of 7x squared. It's just 7x squared. The bases are the same. They technically cancel out, and you just get whatever is left.